Yeah, hi everyone. I hope you're doing awesome. So let me set the context for today's video. So if you are using concurrent queue for producer consumer scenarios in C Sharp, then might be you are wasting CPU cycles or risking data loss without even knowing it. So today I'll show you like why exactly concurrent queue struggles with the async patterns and how channel solves these problems elegantly. Okay, so let's talk about a common scenario of your producer consumer patterns. Suppose you have one or more producers. I'll check later. Okay, so suppose you have one or more producers which are generating data that could be from reading from a files or calling APIs or processing events, and on the other hand you have consumers which is processing that data that could be like saving to a database, sending notification or performing calculations. But you need a queue in the middle to buffer this data, and the natural choice seems to be your concurrent queue. That is correct because it's your thread safe, and it's in your standard library, and it is designed for actually your multi-threaded. But here's a problem. Your concurrent queue was actually designed for synchronous, not asynchronous, synchronous multi-threaded scenarios, not for asynchronous producer consumer patterns. So your concurrent queue come with a 4 pain points that we'll see today, and then I'll show you like how channels solve all of these problems in a clean and async friendly code. So let's dive in. Let me quickly share my screen and see you all there. Cool. So just allow me a moment. Let me share my screen. All right. I need this, not this. I have to adjust few things again. Okay. Uh, cool. Hey, what's up? Oh, here's the camera. Hey, what's up? I hope I am audible. Screen is visible. Cool. So, this is the small architecture I have drawn, and where we are covering the 4 pain points of your concurrent queue. So, it's your concurrent queue producer consumer pattern, the pain points. So, what I have done here, I have just this high level architecture for you, and for the same, we have code as well. Let me check one thing. Do I have code for this? Cool. So, yeah, we have code for this as well. Uh, so here's the code, and the same. This is the same code whatever we have in the architecture. So we'll see parallelly like whatever in the architecture and what is the code and what are the 4 pain points. Cool. So we'll start one by one. So the very first. Uh, cool. So currently I'm here. The first pain is busy waiting. Busy waiting wastes CPU checking constantly. Okay, so rather than just covering one by one, I'll first explain you the architecture. So suppose we have producer here, we have consumer. So as I mentioned, like we need a queue in the middle to buffer this data from producer to consumer. So we are using here, we are referring to the concurrent queue. Cool. So this is our producer. So suppose this is just enqueuing or pushing the messages into the queue. So suppose here we just processed or pushed the message 1, and this is our queue. We are pushing message here, then message 2, then message 3. Cool. All message sent, and then we are manually calling your CTS cancellation token dot. We are just calling them to cancel, and here our producer finishes. So let me also open the code side by side, so then you will relate with the code. So currently we are talking about the first pain point. Although the code is similar, we are just referring to the like what are the pain points with the different methods. So first we'll go in this. Okay. So as I mentioned, we have queue. I have created concurrent queue. We have CTS, your cancellation token source. We have loop count, just to show you the better stats, like what actually happens, how many time loop runs and continuously checking in your CPU cycle wastes. For all those, we have queues, we have CTS, and here we have the producer. I am just calling it as a slow producer because here we are just using await your task dot delay. Cool. So we have producer, we have queue. Currently we'll focus on these two things. It's coming, yeah, it's coming in the screen, like producer and queue. So producer is like pushing or enqueuing the messages into the queue, like 1 2 3, or what you have done. So starting console, you can read here, it's nothing fancy or new here. The main is this, your producer. Now we have task dots run here. So okay, so if you don't know about what is task dot run and why we haven't used the thread here, so I already have a video on my channel where I have covered your async await task thread and the best practices for those. So if you don't know, or if you wanna just rebrush your skills on that, go and check it out. Video is just popping on the screen right now. This is the video. Just go and check it out. You will feel better. Because sometimes if I forgot, I worked on this, but seems like what was that? So I just go back to my my video and I watch that video and I just brush up all the skills, like, oh yeah, this was in the task and this was in the that. Okay. So but now in my day-to-day life I am using your task, and so I keep remember this syntax for all this. So if you don't know, so you can go and check it out there. Cool. So here I've created one task, and here we have loop from 1 to 3. And what we are doing, we are just delaying because it's our slow producer. So because in production, like, it takes time. Suppose I mentioned like producer for generating data, it could be from reading from the files or could be calling APIs. So it takes time to process the data. Then we are just enqueuing into your queue, enqueuing is pushing into the queue, and we are just consoling here. And then we are just signaling or sending the cancellation. Basically, we are calling the cancel method of your CTS cancellation token source. Cool. So this is like 1 2 3. These three messages we have just pushed into the queue and manually called this all message sent. If our all of the messages has been sent, so this is the conditional here. If you observe here, like, our loop has been terminated because it was till 3. So all the messages has been sent or enqueued into the your queue. Then we are calling cts.cancel. If yes, manually call cts.cancel. Just remember, we are manually calling here. This will the relating, so this will come into the video later, like why manually. So if no, then producer finishes. Cool. Perfect. Then we have queue here. So we created this queue, and now inside queue we have all these. I have started the video now. Yeah, I thought that I am just, no, it's recording. Oh yeah, yeah, it's recording. I forgot like whether I clicked on the start or not. Cool. So where were we? We were at queue. Yeah. So now we have message 1 2 3 inside our queue, and queue add. Here we have unbounded and no back pressure control. We'll see this later. We'll talk on this, like what is unbounded and what is back pressure here. Cool. So now we are good with producers. We are good with queue. Now there is a consumer part. ये आपको देखने में थोड़ा सा लग रहा होगा कि भाई ये क्या इतना हाई लेवल है कंज्यूमर, but trust me, it's a super easy, nothing fancy here. Just whatever we have written in the code, same we are just the whatever we have written in the code, we are relating with this diagram. Cool. So now our consumer. So let me go to the consumer first. So here we have the consumer with busy waiting. Okay. So I have created the stopwatch here, and this is our consumer. Again, our task I have created. So this is the consumer. Consumer starts. There's a while. So yeah, we have while. And what is this while? We created one CTS cancellation token source. When your CTS dot token dot is cancellation requested, till cancellation is not requested, means like we are calling this cancellation here inside producer till this is not called. Like अभी तक हमें सिग्नल नहीं आया कि आपको स्टॉप करना है, कैंसिलेशन रिक्वेस्ट नहीं आई है, तो आपका ये लूप चलेगा. कूल. उसमें हम क्या कर रहे हैं, लूप को इंक्रीमेंट कर रहे हैं, लाइक हाउ मेनी टाइम्स वी लूप और वी आइटरेटेड, देन while cancelled. Then what we are doing, we are checking check queue, or we are just trying to pull or dequeuing the messages from the queue. So if queue dot try dequeue, so what we have inside try dequeue, we are just this is the standard syntax. I don't think so I have to like walk through with this. So if there is a message in your queue, like we are dequeuing that, then we'll simply consoling like we have consumed or processed or got the message. Else what we have, if there is a message, we are processing that message, and we are just going and check. Again, you can relate with this arrow. Yeah, this arrow. Check again. If there is no message, we are calling thread.sleep. We are calling thread.sleep. This we have to, because without this your CPU hits with the 100%, or your or your CPU utilization would be 100%, and we won't be able to do anything. So it's a pain. Like even though our queue is empty, we are still checking. Like, is there any data? Is there any data? Because we don't get the cancellation token yet. Cool. So for that, here we are just sleeping our thread, but still our loop is running. We are incrementing the count and we are checking again. So what if, okay, so here we got the cancellation. So what we'll do, we'll stop like dequeuing the messages from our queue. We'll just go with the drain remaining items. So then your while loop would be terminated, and here we are just calling all those, and we are just stopping our stopwatch here. And these are the stats. Don't go with the pain 2 as of now. We'll first cover or understand your the stats. Here we are just consoling the total time, loop iteration, wasted checks, and whatever count was there. Let me run this so it will make more sense. We can comment this out as of now, and let me run this. Meanwhile this is running, so here we will just drain the remaining items. This is in the coming section in the video, like draining items, and I'll show you. Like here we have specifically like the raise conditions between the, like how we can lose the data. Cool. So for draining items, we'll like get whatever in the queue or left, because what we were doing, when producer completes producing the messages, it's just calling the cancel method, which means it has stopped the producing the messages, and now consumer can stop. But there could be a scenario like your consumer was slow, and still there are items in the queue which are left and yet to be consumed or processed. Then we have to drain or get all those items. For that we will have drain remaining items, and consumer finishes, and you can see this cancellation token we are getting from this manual call. This arrow, you can dashed arrow relate with cancel signal. Cool. So we have our console here. Starting slow processor, one message every 2 seconds, and message 1 got message 3, and Here what we have, total time this loop iterations. Now can you check these stats? Total time it took 6035 ms. Loop iterations 57. Wasted checks 54 because only there were 3 messages and we checked for like 57 times. We are just wasting our checks, our CPUs. So the problem, like consumer wasted CPU checking 57 times for just 3 messages. And even with thread.sleep, we are still pulling unnecessarily.
Hello, I think I am audible. Screen is visible. So this part was missing. I didn't realize that message 3 was not consumed. So like as in the diagram there was like drain the remaining items. So this is the loop. Like I have just added the comment or like a log here. Like whatever in the rest of the items are in the queue, we have to like consume that. So if I'll run this, so we'll get the output like message 3 has been consumed now. So let's watch here message 1 2 and like producer has been pushed the message, but I guess our consumer is slow for reading the messages. So earlier your producer passed the cancellation or call the or has been signaled like cancel, I have produced all the messages, but your consumer was slow, so it got message 3 later because the while loop, the constant pooling was terminated, and after that we have to drain all the items from the queue. So for that we have this. Now consumer got message 3. Now you can continue with the flow.
Now, you might get a question here like, here we are using task.delay and here we are using thread.sleep. What is the difference? Let me minimize this so this will come under one frame. Yeah, here we have on line number 47 we have task.delay and here line number 70 we have thread.sleep. So could you tell me the difference like when we use task.delay and when we use thread.sleep? Just comment it down. I definitely read your comments. कमेंट करो, मैं पक्का पढ़ूंगा आपके कमेंट्स. Just give me a sec.
Okay, so basically when we use task dot delay, which means the control has been sent to the caller thread or back to the thread pool. Like your thread is free, you can just use or utilize this thread to process or do another job. But when you call thread dot sleep, your thread is blocked, you cannot do any other job. Here we are just blocking our thread. Like this should not perform any other job, it will not go back to your thread pool. We are just holding this, will not do, we are not doing anything with this thread. So here our thread is free, but here our thread is blocked, we cannot do anything with that. So this was your first pain point. So like busy waiting wastes CPU checking constantly because like there was no data, still we were checking because there were only 3 messages and we checked for 57 times constantly in the loop. The second, like manual completion must remember to signal no error propagation. Like we have to manually, we have to remember this, like we have to call cts.cancel, else what it will do, like your consumer will run infinitely in the loop. Do we have that here? I have, like we'll go to the second method now, like demonstrate manual completion. So this is the same code, nothing fancy here just we have to remember this. Okay, we have to remember to do this, called cts.cancel, because else your consumer will run, because here we are working or just signaling like I have done producing the messages, you have to stop consuming, and then we what we are doing, we are just draining all the messages. And I'm not sure I have written the code for draining all the messages. If not, then it's a pretty or super simple. What you have to do, you have to just run a loop on the your DQ, your queue, and try to DQ the messages till there are messages in the queue. You just have to pop all those messages. Isn't this similar to like you have to merge two linked list, and once you like sorted list, once the first list is completed, so what you do, you just take the uh, pointer of the second list. Just a second यार, आपको नॉइज आ रही होगी, बाहर ट्रैफिक है, होल्ड ऑन. जाओ भाई जल्दी जाओ. ओके, सो लाइक जब आपकी फर्स्ट लिस्ट कंप्लीट हो जाती है, लाइक यू कंपेयर एंड चेक योर फर्स्ट लिस्ट हैज़ बिन ended. So what you took, just took the second pointer and append at the end of the first list. So remaining items, same here, you have to just drain the remaining items from the queue. So this is the point, like you have to remember for the second, like you have to call cts.cancel, because else your this while loop will be run infinitely and your 100% it will go with the CPU utilization, and that's a pain. Okay, so also if you are wondering like what is this task dot when all, and because there we have one more, we have task dot wait all. So what is the difference, do you know? I would say just go and check it out. I have entire video on my channel where I have covered this, like what is task dot wait all. So why we have to use task dot when all in the production environments. So I would recommend go and check it out, that video. Cool. So basically when you call the wait all, it basically blocks the your main thread and your entire application is freeze. You cannot run the other threads, but when all is your task is running in the background, but your application is ready to move, or your main thread is not blocked here. Your application can perform and do other jobs, means other thread can runs and do their job. Cool. So we'll not go with this. So next pain point we have with our concurrent queue is no back pressure, queue can grow unbounded memory issues. So what does this mean? Just a second यार, फिर से नॉइज आ रही होगी, बाहर ऑटो जा रहा है. Let them go. So the next pain point is no back pressure, queue can grow unbounded memory issues. So here if you observe, our queue is ended and this is unbounded. So bounded, there are two types like bounded and unbounded. So in production environments we recommend or prefer to go with the bounded queues, because unbounded is your unlimited, there is no size, no bound, but bounded is there is size. Because in unbounded it basically takes the memory of your like I would say the resources like your RAM or the servers, it just take the memory from those. And because of that, like if it grows, like your queue grows, then at the end your server crashes because it consumes the memory from your resources. Then in production you get the errors like memory is running out, and the another one is your server crashes because no memory left, because this takes. And what is back pressure here, like no back pressure control? Back pressure refers to like when your bounded queue reaches its capacity and attempts to add more items into the queue, then it will block your producer, like, or it could return an error like I cannot because I have reached my maximum limit. So in that scenarios there are ways like what you can do, you can just drop the newest or latest, and those are ways, and that we'll see in the channels, we'll define those properties. So this is for your bounded and unbounded, but there is no back pressure. Like back pressure means like once we have reached the limit, so we cannot add, but there is no such way to define them. So this is also a pain. Now the next pain is raise condition items might next pain is race condition items might be lost between cancellation check and drain. There is a possibility. So suppose race condition, I believe you all know, like whenever we are trying to change the shared resource, okay, so items might be lost. Suppose we are on the producer and we have just passed the cancellation. Our consumer was slow, and suppose it was processing the messages, and the moment it got your cancellation, it stopped the messages, and afterwards what it will do, it will just start draining the remaining items. But the moment it was processing the messages, like your consumer, and it got the cancellation, there are high chances the current data will be lost, because it items might be lost between cancellation check and drain. So this you have to care about, but these are the pain points in your concurrent queue. We do not have much access, or I would say control, here in your concurrent queue. And like in the methods, I have just uh, explained these all. Like here, this was the third, no back pressure. So here what we were doing, we were just adding, like producer is fast, we were adding 1,000 messages, and like this here we are just enqueuing. I have just one check here, like if it's 200, then I'm just consoling like these number of messages has been pushed, and this is my queue size. But our consumer is slow, as I mentioned, so there are high chances like there will, like consumer is slow, and there would be a moment like producer is just pushing all the messages and consumer haven't like consumed the earlier messages, and it's getting more of the messages in your queue. So this is also a pain point, because we do not have any back pressure and all those things here, because there is no such back pressure, and your memory can grow unbounded. And for the fourth, I have what I have here, no built-in error propagation. So suppose like here we were just adding 5 messages into the queue. Although if you'll understand or observe, although if you observe, the entire code is same. I have just modified a single line over there to like simulate like what is the pain point. So like for here, in the second one we just focused on the manual cancellation. In the third one we saw like back pressure, there was no control, because we do not have control. Our unbounded queue is there, and we are just pushing our product. Our producer is fast, and we are just enqueuing all the messages very fast, but consumer is slow. It takes time to like process the message and enqueue from your queue, so there might be a problem. Okay. And the four, complex error handling. So if you observe here, so this is our fourth pain point. Same, we have queue, we have CTS. Suppose we have producer exception here. So what we are doing, I am just enqueuing up to 5 messages here, but when I am at third iteration, I am just throwing an exception, producer failed. But there is no built-in way, because I have to throw the exception, and your consumer will, how it will know like why your producer has stopped, because the moment I got the exception, I'm just sending the cancel, but no built-in way to signal error. I'm just canceling it. So how the your consumer will get to know like whether this is intentionally, like producer has completed all the like producing messages, or how it got failed, or whether it is something broken. Okay, so we just cancel and hope consumer figures it out. Why in production system we cannot hope something like this? And here inside consumer, our this while loop will terminate it if I get the cancel, then your consumer stopped. Pain is consumer has no idea why it stopped. Consumer, was there any error? No way to know. did producer finish normally? Can tell, because we don't know now. We just there the only producer and we got the exception, and we what we are doing, we were just sending we were catching the exception in the catch block, and we were just calling the seedcase.cancel, but that is not the way. So the problem is no built-in way to propagate exceptions. Consumer cannot distinguish like error versus the normal completion, must manually pass exceptions through shared variables and raise conditions with errors checking. So but here we have to handle these all things manually, but there is one solution to all these problems or the four pains. What is that? That is your channels. Yes, so in .NET we have channels where these all things will be handled automatically. There is no such like your data loss or CPU cycle wastage. The channels will cover in the next video. It's getting long video, so channels will cover as a part 2 of this video. If you found this video helpful or useful, then also like I'll attach the code in the description, so you can go and check it out and refer to the code. And if you have any doubt, you can just comment it down at particular timeline or time frame, like what is this. I'll help you to like clear that doubt. Although I'm providing the code as well, you can just can understand the code as well. I'll also attach this architecture as well. Okay, so yeah, that's all for this video. If you found this video helpful or useful, then don't forget to like, subscribe or share. I'll see you in the next video. Till then, keep learning, keep growing. Bye bye. And थोड़ा सा एक लाइक और सब्सक्राइब तो कर ही सकते हो अगर आपको ये वीडियो अच्छी लगे, बिकॉज एफर्ट्स लगता है थोड़ा सा पूरा वीडियो को बनाने में, फिर एडिट एंड ऑल दोस. अगर आपको थोड़ी सी हेल्पफुल लगे तो यू कैन डू. So but yeah, channels we'll see in the next video. So bye bye.